Hi everyone. First of all, I'd like to thank the organizer of this conference. So, my name is Al-Khadher Khalil. I'm PhD student from the laboratory Electronics, Instrumentation and Energy, Faculty of Sciences, Chouaïb Doukkali, University Al Jadida, Morocco. The title of my work is Effect of Difference Variable Leg Geometry on the Performance of the Thermoelectric Generator. My presentation today will be divided into 5 important sections. Firstly, I will start by introduction. I will show to you description of the studied models. My third point will be about mathematical model. After that, results. And finally, I will finish by a short conclusion. So, many energy sources waste nearly 60% of energy without practical applications. Therefore, the thermoelectric generator are used to take advantage of the wasted heat and convert it into electricity. A thermoelectric device generates a voltage when there is a different temperature on each side and when a voltage is applied to it, it generates a difference in temperature. This effect can be used to generate electricity, measure temperature, call objects, or hit them. Let me now move to the next slide. Description of the studied models. In this study, the thermocouple are modeled and simulated for geometrical forms: pin leg, rectangular leg, cylinder leg, and coil leg with the same leg volume. All models have the same cross-sectional area of the hot ceramic. Now, I'm going to talk about mathematical model. In the thermocouple model, the lead telluride motivate of p-type and n-type is used. Seebeck coefficient, electrical conductivity, and thermal conductivity of p-type and n-type are calculated using the equations in the following table at the average junction temperature. To simplify the mathematical model, heat conversion, heat and heat radiation on all surfaces are neglected. In addition, electrical contact resistance and thermal contact resistance are not considered. It is also assumed the leg surfaces are isolated. The internal and thermal resistance for the studied models are calculated by the following equations: internal resistance, thermal resistance. The heat of the hot side and cold side can be written by the following equations: hot side and cold side. Current and output power and efficiency can be calculated by the following equations: current, output power, efficiency. I will present to you results. The geometric forms affects the internal temperature distribution of material. Therefore, the forms rectangular leg and cylinder leg presented linear both. while the forms bean leg and queen leg presented curved path. Figure show variation of temperature with leg length. Figures show the values of the internal resistance and thermal conductance of the studied models. The rectangular leg presents less electrical resistance and the highest thermal conductance compared to other forms, while the queen leg presents the opposite. The rectangular leg generated the highest output power, while the queen leg generated the highest efficiency, as shown in the figures A and B. The following table show the values of the output power and the efficiency of the studied models. Finally, conclusion. The leg geometry plays the important role in the distribution of temperature with the length of the leg, where the forms of bean leg and queen leg give a curved path, while the forms of rectangular leg and cylinder leg give a linear path. Although all studied models have the same leg volume, the variable leg geometric affects the internal resistance and the thermal conductance. The rectangular leg generated the highest output power and the less efficiency, while the queen leg generated the highest efficiency and the less output power. The rectangular leg model generated the best performance compared to all studied models. Thank you for your attention. Hi.